The Internet Protocol allows two computers to exchange messages across a network that's built up out of many different link layers. It does so through addresses. An IP packet has a source and a destination address. Routers decide which link to forward a packet based on the packet's destination address. Let's look in detail at what IPv4 addresses look like, how they are formatted, and how they are allocated. The original goal of the Internet Protocol was to take many different networks and stitch them together. For this to work, the protocol needed a way to refer to a computer that was independent of the network it was on and was unique. So a computer on an IBM network and a computer connected to a router over a serial line can talk to each other and need a way to address each other. Today, IPv4 addresses are a bit more complicated. They're not totally unique due to a bunch of special cases and uses, but for now, let's just assume that they're unique. An Internet Protocol version 4 address is 32 bits long. These 32 bits are often written as 4 octets, that is 4 8-bit values, in the form A.B.C.D. Here are 3 examples: 171.64.64.64, 128.30.76.82, and 12.22.58.30. Every device connected through IPv4 has an IPv4 address. The IP layer delivers packets whose destination is this address to that device. In addition to an address, a device typically also has something called a net mask. A net mask tells you which IP addresses are local, on the same link on the same network, and which require going through an IP router. For example, think of a laptop on a wireless network. In order to send a packet to another device in the same wireless network, you don't need to go through an IP router. You can, in theory, just send the packet directly to the other device since it's in the same wireless network. A net mask is written as a string of consecutive ones, starting with the most significant bit. A net mask of 255.255.255.0, for example, means the first 3 octets are all ones. 2 to the 8th minus 1 is 255. And the last octet is 0. This means that an IP address which matches the first 3 octets, 24 bits, of your IP address is on the same network. A net mask of 255.255.252.0 means that net mask is 22 bits long, while 255.128.0.0 is a 9-bit net mask. You can tell whether 2 computers are in the same network by taking a bitwise AND of their addresses with the net mask. If the resulting addresses are equal, they are in the same network. Let's see what this looks like on my computer. I can open up a terminal and use the ifconfig program. My computer is connected to the internet over Wi-Fi, which happens to be the link named EN1. If we look inside the information for EN1, we can see that my Internet Protocol version 4 address is 192.168.0.106, and my net mask is 0xFFFFFF00, which is hexadecimal for 255.255.255.0. This means that if I send an IP packet to an address beginning with 192.168.0, I should send it directly, but if it doesn't begin with 192.168.0, I need to send it through a router.